All right, we're going to do some dimensional analysis. So, first we're kind of going to talk about just the concept of dimensional analysis. Dimensional analysis, actually I'm going to put this to the side so I have some more room. There we go. Okay, dimensional analysis is based on the concept that if we have x, y, z over x, y, then the x will cancel out because it's on top and bottom. The y will cancel out because it's on top and bottom. And we will just be left with z. Okay? Now, in dimensional analysis, we use conversion factors. Okay? Some you'll be expected to know, some you will be given. Now, for this first one, 17.50 days into seconds. So any dimensional analysis problem ever, we start with our given. So 17.50. I'm just going to write D for days. You can shorten units in certain instances. And we always put that over 1. You don't really have to put it over 1, but it just makes it cleaner and easier to see. Okay? So this is our given. Now we're going to start by doing our conversion factor right next to it. Okay, we always, whatever is on top, we want to cancel that out. We want to get rid of it. So we want that unit on the bottom, so days. Now, we want to convert days into seconds. There's not really an easy conversion for days to seconds, but there is a really easy conversion for days to hours. So we're going to put hours on top instead of seconds. Okay, now there are, as hopefully we know, 24 hours per 1 day. So then days cancels out, we're left with hours. Okay, now hours is not where we want to be. We want to be at seconds. So we need another conversion factor. Now again, hours is on top, so we're going to put hours on bottom. And again, there's not really a very well-known conversion factor for hours to seconds, but there is a very well-known for hours to minutes. So 1 hour has 60 minutes in it. Again, hours cancels out. We're left with minutes. Again, that's not where we want to be. So we need another conversion factor with minutes on bottom. And this time there is an easy conversion from minutes to seconds. So we're going to write seconds on top. In 1 minute, there are 60 seconds. Okay, again, minutes cancels out. We're left with seconds, and this time that is where we want to be. So we do not need any more conversion factors. So now we just take all of our top numbers, multiply them together. So 17.5 times 24 times 60 times 60. And we get a really big number that I hopefully have room for. 151,200. And we take all our bottom numbers, 1 times 1 times 1 times 1, and we would put that on the bottom, but since 1 times 1 times 1 times 1 is 1, and 151200 divided by 1 is 15120, we can just call that good and put our label on, and that is our final answer. Okay? And if you just give me 1 second, I'm going to erase this stuff down here. Whoops. And we can do the next one. Okay, so next one is 1.124. Oh, and also, actually, I'm sorry, I forgot to do sig figs in the previous one, but lucky for me, it already is done. So sig figs, we have 4 right here, so that means since this is multiplication and division, we're going to go by the fewest number of sig figs. So that has 4, so our answer should also have 4, which it indeed does. 1512. That's 4, and then these 2 zeros are not significant, so there we go. Okay, now, back to letter B. 1.124 kilometers, and we want to get that to centimeters, okay? So, first step, we put it over 1. Then we do our first conversion factor. Kilometers goes on bottom, and then we want what we're converting to on top, but there's not really a good conversion factor for kilometers to centimeters, so we're just going to go kilometers to meters. Now, there are 1,000 meters per 1 kilometer. Kilometers cancels out. We're then left with meters, which is not where we want to be, so we need another conversion factor with meters on the bottom to cancel it out. And then if we want centimeters on top, there are 100 centimeters per 1 meter. Meters then cancels out. We're left with centimeters, which is where we want to be. So now we do our math. 1.124 times 1,000 times 100, and we get 11240, again over 1, which is just going to be 11240, and again we have 4 sig figs, so our answer should have 4 sig figs, so our final answer is 11240. Whoop, I did an extra 2 there. There we go. And then there shouldn't be space here. 11240 is our final, oh, I'm sorry, centimeters is our final answer. Okay? All right, now we're going to scroll down a little bit here. Okay, now, next one. 16.54 yards to millimeters. All right, so again, we are going to start with our given. 16.54 yards over 1. We do our first conversion factor. Yards. Now, there's not a good conversion factor for yards to millimeters, so we're going to go yards to feet. Now, as hopefully you know, there are 3 feet per 1 yard. Yards cancels out. We're left with feet. That's not where we want to be. So we do another conversion factor. Feet on bottom. Not really a good feet to millimeter conversion factor, so we're going to do inches. There is 12 inches in 1 foot. Feet cancel out. We're left with inches. It's, again, not a good conversion factor. I'm sorry, I'm skipping ahead. Inches on bottom, or that's what I meant to say. Inches is not where we want to be, so we need another conversion factor. Inches on bottom. Not a good conversion factor for inches to millimeters, but there is one to centimeters. Okay. There is 1 inch per 2.54 centimeters. Inches cancels out. We're left with centimeters, not where we want to be. So we do another conversion factor. Centimeters on top. And then millimeters, there is a good conversion factor. For every 1 centimeter, there are 10 millimeters. Centimeters cancels out. We're left with millimeters. We do all our math. 16.54 times 3 times 12 times 2.54 times 10. And we get a really big number. 1512. Oh, I guess that's not that big. Didn't see the decimal. 0.176. And that's millimeters. Okay. So now we need to look at sig figs. We have 4 sig figs here. We have more than 4 sig figs here. So our final answer is going to be rounded to 1, 2, 3, 4th sig fig. So it's the 2. This 4 does not round up the 2, so our final answer is going to be 15120. We can't just get rid of that 4, right? We have to keep the place value, so we replace it with a 0, okay? And then millimeters. And that's it. We're good to go.